On an oyster reef at the bottom of the bay, what's the critical mass needed to get a chain reaction started? To answer that question, the Department of Natural Resources created two kinds of test plots. First, we planted oysters in low density along the river bottom. Two years later, we came back to those exact plots using GPS to locate them.
I'll put mine on the outside, maybe.
Here it comes. And we headed back to the bottom of the bay with our cameras. 2 years later, this is what lightly seeded areas looked like. There are very few live oysters and lots of shell. There is little or no community associated with this lightly planted plot. Does density make a difference? Right next door to the low density plots, the DNR put down a much heavier load of seed oysters, trying to create high density plots. The results are pretty remarkable. Oysters are growing so densely here, they form a reef that may resemble the ones that were here 100 years ago. When we looked closely, laying the camera right down on the reef and leaving it there, we made some interesting discoveries. Most of the oysters here are actually vertical. They're sticking straight up from the bottom. This is the way they grow naturally when they're undisturbed by harvest gear. On these dense bars down along the bottom of the bay, we found all kinds of animals hiding and feeding and making themselves right at home. Blennies and gobies and grass shrimp were all over these bars. And blue crabs came here also, looking for prey and for shelter so they can hide out from predators and from scientists with video cameras as well. That's really cool.
But the visibility is not that bad with the camera.
No, it's not.
It's terrible on the bottom.
We discovered this blue crab burrowing under a clump of oysters, crawling into its cave and bringing out clawfuls of mud and shell, dumping it, and then cleaning his teeth, so to speak. It's an excellent demonstration of the habitat oyster bars provide. Here we can see several striped bass or rockfish cruising just above a restored oyster bar. They're probably hunting for gobies and blennies and little blue crabs. And they know this restored oyster bar is the place to find them. We've suddenly realized that we have the capability to restore some of these reefs. Reef restoration work that we've done so far has demonstrated that reef restoration can work, that when you do restore an oyster reef, we can get good ecological things to happen. Most of the areas that we have now will not recruit actively, so we have to go plant those oysters. But now we've discovered that when we do that, we do develop these communities, and we do see an enhancement of the bottom, and we do see an enhancement of the ecosystem. So it looks like we have the capability of restoring these benthic ecosystems. Seen good growth and survival for up to 5 or 6 years now at many sites that are in the upper reaches of many of the tributaries, the Chester River, the Choptank River, the Severn, the Magathie. that still encompasses probably tens of thousands of acres. Still a lot of bottom.
We're not going to get out of this thing in 2, 3, 4, 5 years. We're in this for the long run, but it's important enough that we do, that we stay the course and bring oysters back to the bay. The bay is not going to be healthy, not like it was, until we have large expanses of healthy oyster reefs out there.
We're only beginning to understand how to restore oyster bars in the Chesapeake Bay, but we've gotten a good start. The data we've collected tell us that high densities of oysters, planted and then protected from harvest, will yield a rich benthic community that will be very valuable to the bay's ecosystem as a whole.